Great AI models do not just classify, they show confidence, uncertainty, and probability behind every important business decision they make. Now let's look at classification is not just yes or no. Classification models predict categories. But in real business problems, a category alone is often not enough. A model may say fraud, spam, or high risk. But the more useful question is, how confident is it? Probabilistic classification gives both a prediction and a probability. That probability helps humans make better decisions. This is where classification becomes more practical for business. Now let's look at what you will learn. First, we will understand probabilistic classification. Then we will compare simple classification with probability-based classification. Next, we will see why confidence scores matter. After that, we will explain naive Bayes and logistic regression. Then we will use business examples like spam, fraud, churn, healthcare, and sentiment analysis. Finally, we will cover beginner mistakes and practical takeaways. Now let's look at what is classification. Classification is a supervised learning task. It predicts a category or class. The answer is not a number like sales or price. The answer is a label. Examples include spam or not spam, fraud or not fraud, positive, negative, or neutral sentiment. Classification helps AI make category-based decisions. Now let's look at what probabilistic classification means. Probabilistic classification predicts a class with a probability score. Instead of only saying spam, the model may say 92% spam. Instead of only saying churn, it may say 78% churn risk. This probability represents model confidence. It helps decide how strongly to act. A 51% probability and a 95% probability should not be treated the same. Probability adds useful context to a category prediction. Now let's look at classification versus probability. A normal classification output may look simple. It says yes or no. But probability shows how likely each class is. For example, an email may be 92% spam and 8% not spam. A customer may be 78% likely to churn. A transaction may be 96% likely to be fraud. Probability turns classification into a decision support tool. Now let's look at why confidence scores matter. Confidence scores help decide what action to take. If fraud probability is very high, the transaction may be blocked. If fraud probability is medium, it may be sent for manual review. If probability is low, the transaction may pass normally. This creates a smarter decision process. The model does not need to treat all predictions equally. Business action can depend on confidence level. Now let's look at thresholds explained simply. A threshold is the cutoff used to make a decision. For example, if churn probability is above 70%, mark the customer as high risk. If fraud probability is above 90%, trigger an alert. If spam probability is above 80%, move email to spam. Thresholds convert probabilities into actions. Different businesses may use different thresholds. The right threshold depends on cost, risk, and business priority. Now let's look at naive Bayes explained simply. Naive Bayes is a probabilistic classification method. It uses probability to decide which class is most likely. It is often used for text classification. For example, it can classify emails as spam or not spam. It looks at words in the email. Then it estimates which class is more probable. It is simple, fast, and useful for many beginner examples. Now let's look at naive Bayes email example. Imagine an email contains words like winner, free, and urgent. In past data, these words may appear often in spam emails. Naive Bayes uses this pattern to estimate spam probability. It does not understand the email like a human. It uses word patterns and probabilities. If spam probability is high, the email may go to the spam folder. This is probabilistic classification in action. Now let's look at why it is called naive. Naive Bayes makes a simplifying assumption. It treats features as if they are independent. In real life, words and features may influence each other. That assumption is not always perfectly true. But the method can still work surprisingly well. Especially for text classification and document filtering. It is useful because it is simple and efficient. Now let's look at logistic regression as a classifier. Logistic regression sounds like regression, but it is used for classification. It predicts the probability of a class. For example, it can predict the probability that a customer will churn. It can predict whether a patient is high risk. It can predict whether a transaction may be suspicious. The output is usually a probability between 0 and 1. Then a threshold converts that probability into a class. Now let's look at logistic regression example. Suppose a business wants to predict customer churn. Features may include monthly spend, usage, complaints, tenure, and support tickets. Logistic regression studies how these factors relate to churn. It may predict a 76% churn probability. If the business threshold is 70%, the customer is marked high risk. The team can then offer support or retention action. This is how probability supports business decisions. Now let's look at business example, spam detection. Spam detection is a classic classification problem. The model looks at words, sender details, links, and email patterns. It estimates the probability that an email is spam. Low-risk emails stay in the inbox. High-risk emails go to spam. Medium-risk emails may be flagged or reviewed. Probability helps reduce both false alarms and missed spam. Now let's look at business example, document classification. Companies handle thousands of documents. These may include invoices, contracts, complaints, resumes, or support tickets. A classification model can assign each document to a category. It can also give confidence scores. High-confidence documents can be routed automatically. Low-confidence documents can go for manual review. This saves time while protecting quality. Now let's look at business example, fraud detection. Fraud detection depends heavily on probability. A model may analyze transaction amount, location, time, device, and past behavior. It may estimate fraud probability. Very high-risk transactions can be blocked. Medium-risk transactions can be sent for review. Low-risk transactions can pass. This is useful because fraud decisions have real financial impact. Now let's look at business example, customer churn. Churn prediction identifies customers likely to leave. The model uses customer behavior, complaints, usage, payments, and service history. It predicts churn probability. Customers with high churn probability can receive retention offers. Customers with medium probability may receive support outreach. Low-risk customers may not need immediate action. Probability helps companies prioritize effort. Now let's look at business example, healthcare risk. Healthcare classification must be handled carefully. A model may estimate whether a patient is high risk. It may use symptoms, lab results, age, history, and visit patterns. A probability score can help prioritize review. But the model should support doctors, not replace them. Human judgment is essential. In high-stakes areas, probability must be used responsibly. Now let's look at business example, sentiment analysis. Sentiment analysis classifies text as positive, negative, or neutral. Businesses use it for reviews, surveys, and social media comments. A model may say a review is 85% negative. This helps teams identify customer pain points. It can also separate urgent complaints from general feedback. Probability helps decide which comments need attention first. This turns unstructured text into business insight. Now let's look at probability helps better decisions. Probability helps businesses avoid one-size-fits-all decisions. A low-risk case can be processed automatically. A medium-risk case can be reviewed. A high-risk case can trigger urgent action. This is useful in fraud, healthcare, finance, operations, and customer service. Probability supports prioritization. Better prioritization leads to better use of time and resources. Now let's look at common beginner mistakes. One mistake is treating probability as absolute truth. A 90% score still means the model can be wrong. Another mistake is using the same threshold for every business problem. Beginners may also ignore false positives and false negatives. Some forget to check whether the model is calibrated. Others trust high confidence without checking data quality. Probabilities are useful, but they need evaluation and human review. Now let's look at final content recap. Classification predicts categories. Probabilistic classification predicts categories with confidence scores. Naive Bayes uses probability and is useful for text classification. Logistic regression predicts class probability and supports decision thresholds. Business examples include spam, documents, fraud, churn, healthcare risk, and sentiment analysis. Probability helps businesses prioritize actions under uncertainty. The key idea is simple: classification tells what, probability tells how confident. To wrap up, here is the key takeaway. You now have a structured overview of classification models in machine learning probabilistic AI explained. Review the core ideas, connect them to examples, and revisit concepts like classification is not just yes or no. What you will learn: what is classification? When practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.